So in this section, I want to play up this idea of modules of existing code that you might want to use to just sort of solve common problems. In this case, I'm going to show you some file system interface stuff, and also how you call an external process and capture its output and like to do something. So you can imagine using Python sort of as you might use Bash, but just sort of as a better Bash to sort of glue something together to solve some sort of utility. So I'll start off in the interpreter here. Fire up Python. And the first module I want to talk about is the OS module. It stands for operating system, I think. And I'm just going to do a dir on it. So I import the OS module. I'm going to look inside of there, and you can see there's all sorts of functions in there. These obviously, set GPID and nice. These are obviously kind of operating system-oriented utilities. Have a very, very kind of a Unixy feeling. In theory, these try to be platform independent. So if you wrote a Python program and it's running on Windows, some of these are stubbed out, where you could call, try to get the current time or whatever, and it's going to translate it. I don't believe it's done perfectly, but it tries. So going through those, there's at least theoretically a degree of platform independence. So I would like to show you a couple. So obviously there's tons of stuff in here. The one I'd like to show you for starters is listdir, that one. So actually I could do help on it just to show you how that works. Remember, so I say os.listdir. So it says okay, what this does, it takes a nice summary. It takes a path, and it's going to give me a list of strings. So what this is going to do is I give it a path to a directory. And then it's going to figure out what all the file names are in that directory and just return it to me as a list of Python strings. So let me get out of the interpreter here. So to demonstrate this, what I thought I'd do is I'll modify the long-suffering hello.py example to just, list files. So I'll say import OS here. I'll rename this list, uppercase L. Let's say this will take a directory. So let's say I'll say file names is equal to, I'm going to say os.listdir of dir. And then just sort of as I've been encouraging you to do for the exercises, well, I'll just print what that gives me for starters. So here I'll say list. So here in the main, I'll just leave it the way it is. So I'll assume that there's one command line argument, and I'll just list it. So hopefully this is in the same directory. So if I say hello of, let's say, dot, then you can see it's it's found. So that I'll do an ls, the other way we can access this information. So there's this .dsstore thing that the Macintosh pathologically puts everywhere. And other than that, you see there's just kind of regular file names. So let me make this code do something a little more interesting. So at least I printed that it's there. So here, let's loop through them. So I'll say for file name in file names. Sort of typical kind of thing. So one thing I can do, if I want to make a path out of this, or what's important to understand is that when you do a listdir to get file names out of a directory, just that file name on its own, just out in space, is not a valid path. Right? It needs to be connected to the directory it came from to make a valid path. So the way I can do that, so as soon as you call listdir, you're disconnecting the file name from path. So you have to realize you've immediately made it. Now with the current directory as dot or something, you might be able to kind of fudge through on some of these, but then you'd have a bug if someone was running in a different directory. So in the OS package, there's a subpart called os.path, and inside of os.path, there are utilities for manipulating file paths, taking them apart, putting them together, that kind of stuff. And again, these are a little bit platform independent. So on Windows or whatever, there's some chance this might work. I'm sorry, it would definitely work. Join takes a directory and a file name and puts them back together in a platform valid way. So that makes a valid path. So I could say print. I'll just print that. And then also there's an os.path.abspath. So I'll do that on the path. And what that's going to do, it's kind of like a PWD. Oh, there's no path there. It takes the path and it's going to just fill it out to be replete. So let's try that. So if I run that on dot, And there's a module. OK, what did I do wrong there? OS. Oh, it's not abs bath. All right. Well, let it be said, my demos do not lack for realism. All right. So here I'm running it on the directory dot. And so then here the first line is it just puts it back together with a slash. I think let's just try it. If I said like dot slash, notice it's smart about not doubling up the slash there, where if you just put it together with a plus, you would have done the wrong thing in there. It would have said dot slash slash. So anyway, so there's a nicety of going through the real utility to do it right. And then here is, this is just on my, oh no, this is on my Unix, my Google box, whatever. That's, that's the full path of the thing. And I'm sort of cheating on just, I could say like /temp and like whatever. God knows what that is. This is some sourcefs thing, whatever. Anyway. So I can, as an argument, I can just give it any directory. It's gonna list it up. All right, so let me go back to, so mundane yet useful, right? You want to be able to manipulate, list, do stuff with directory paths, take them apart, put them together. I've showed you just a few of the utilities. You can look in there. There's all the imaginable utilities you would want for manipulating that kind of stuff. So let me show you. I'm going to drop back into Python here. I want to show you one other one. Just one you want. There's a os.path.exists. It's kind of useful, so I could say, /temp/foo. That's hopefully. I don't actually know if that exists. No, it does. All right, of course. How about Baz? Oh, OK, that's not there. There's also os. I'm not going to run this one. os.maker. So you give that a path if you want to make something. And then finally, one that you would never in a million years would it occur to you to find, but there's a module called shutil. Which I think historically it was sort of like shell utilities. And in shutil, there is a .copy. And what this does is file copying for you. So you give it a source path and a dest path, and it just kind of like does the right thing. Obviously, you could do it manually by reading the bytes of the whatever, but you just, as I always say, living higher in the food chain, you just want to call the thing that does that. I think the name of shutil, it also shows how I think Python has grown sort of organically, right? It's not like a committee got together and said, where for Java, I feel like it's much more top-down designed with the names and stuff. It's not that a committee got together and said, well, I think we should have a file copying utility, and here's what the name should be. It was done. Instead, I'm just guessing, like some guy said, oh, here, I've made this shutil thing. Didn't really give a lot of thought into the name, and it was just kind of useful, and it's open source, so it just kind of got picked up. And so now, by historical accident, that's the slightly obscure name for where that utility is. So typical kind of community-driven open source. It's kind of lovable and powerful, but yet like a little bit undisciplined. Alrighty. So that's stuff I want to show you with OS. Now I want to show you another. I'm going to stick with doing stuff in the interpreter just to reinforce that thought. So the other thing I want to show you is how you launch an external process and wait for it to finish. Like very common kind of, utility, get things done sort of thing to do. There are a bunch of Python modules that do this, a bizarrely large number. I'm going to show you if you only knew one, I think this is the most useful one. There's a module called commands. And inside of commands, there's a function called getStatusOutput. I'll do help on it. Oh, boy, the help is pretty short. What it does is it runs that command. So it's going to shell out as an external process. It's going to run that command, and you're going to block. So it causes you to wait. It's going to wait for that subprocess to exit. And the standard out and standard error of that subprocess are captured. They're not just written onto your standard out and standard error. So the thing is, it's kind of sealed. So once the thing exits, then what getStatusOutput is going to do is it returns a tuple length 2. Returning a tuple is kind of the Python way of saying, well, look, I wanted to return 2 things, or 2 or 3 things, or whatever, so you could just return a tuple. The tuple that it returns is, the first is the int exit code. So just in a very typical Unixy kind of way where you can recover the exit code out of there. And then the second is a big string, which is all of the output of this thing. And in this case, I think it's both the standard output and the standard error kind of catted onto each other. Now, there are a bunch of variants of this if you want to capture the standard error separately, or all sorts of permutations are covered. But this is the one we're going to use today. All right, so I'll get out of here. And I think what I'm going to do is I'm going to modify my, well, here. We'll leave this as list. But I'm going to have it work differently now. So I'm going to say, let's say make this command. I'll say ls minus l plus the directory name. This is kind of weird, right? So as a string, I'm putting together like, oh, here's the thing I'd like to shell out and have it like launch the ls program. And so then I'm going to write a tuple. So I'll say status, comma, output is equal to. Actually, no. Here I'm skipping a step. So the way I like to do these. Well, OK, no, I'll do it this way. Sorry. So the way you call it is I'll say status output. That's the tuple is equal to commands.get status output. And I'll just pass in the command I want to do. And then here we'll just like print the output. I'll get rid of all this. And for normally I would forget to do the import and go through that, but just since we're short of time, I'll go ahead and do it correctly. So import commands. All right, yeah, I think that might work. All right, so go down to the Python. So if I say, I'm just going to give it a dot again. Oh, there we go. All right, so what that did is it put together the ls minus l. It went through the commands module. It launched it. My Python program waits blocks. Eventually, the thing ran. It produced your typical ls minus l sort of output. And then I'm done. All right, so now this is, I'm going to fix this up in a couple ways. I regard this as like not quite right. So one thing I want to do is I want to notice if this thing failed. And the way I'm going to do that, the simplest way is I'm just going to say if status. If the status is non-zero, then I want to notice that there was an error. And so because status is coming through as an int, if it's 0, that's going to count as false. Any other value count as true. So that's sort of the most primitive way of detecting an error here. So then I'm going to say something like print. I think I could refer to sys standard error. Whatever. There was an error. Now, I'm being a little picky here because when you capture the standard error of a subprocess, if I were to sort of squelch it, if I was to just kind of eat it and hide it, it makes the system undebuggable. I mean, if you think about software systems where it's some big thing with a lot of parts, it's the key piece of information when it's used incorrectly, which of course it is that whatever the lowest level was that ran into the error reports it. It raises some kind of message like, hey, this didn't work. And you are really dependent on that low level letting you know. Or put the other way, if the low level fails and remains silent, it's very, very difficult to debug. And I'm pointing this out because this is the rare case where we are capturing the standard error of that thing. And so we are kind of responsible for making sure that it gets reported. And I'll just say something like that. And then I'm going to say sys.exit1. I'm just going to be like, yeah, I'm giving up. I'm terminating. So that is one thing I would want to do. Now the other thing I'm going to change here is when I'm like, suppose you have a bug in your baby names code. You like do the rego expression wrong. And like, really, what are the consequences of that? Oh, well, whatever. Some of the baby name data is a little bit incorrect, or you missed something. I mean, having error in your code, you just get like slightly bad data, which is not that bad. I'm going to say. Now, what if I have a bug here in this string where I'm putting together a command which I'm about to shell out and run as me? And I just want to put out the ramifications of doing that wrong are potentially much worse. Right, that whenever I write command, I'm immediately on this slightly heightened sense of paying attention. I'm like, OK, well, yeah, I could really delete everything or whatever. So just to demonstrate that, what if I were to change this to say rm minus rf star? Well, let's say, why stop there? / star. Right? Oh, I'm sorry. The directory is already there. It's an argument. OK, there. Right? Here, I'll show you. I'm going to save it. Right? Now, if you're anything like me, like I'm like, OK, that's not so good. All right, so here's what I recommend doing. When I'm writing this kind of stuff, I'll say print, about to do this, : comma. Oh, there's the command. And then I'll just like return, whatever. Just don't get to the stuff below. Because you can sort of debug your program, all this other reading of directories or whatever kind of stuff, and you can still have it print, here's the command it's going to do. And so it's more pleasing, I think, to debug it that way. So let's just try this. So I'm going to save it. And that definitely returns, right? OK. Hey, the snapshot directory would totally bail me out here. It's unscrewable. All right, sorry. And I just got out of the wrong button. All right. So what I meant to do is go down here. hello.py. There was an error. What's the problem with that? Did I forget if print, if status print? Oh. Right. Okay. Yeah. That's the wrong. Okay. Never mind that. Let me just. I'm not using the right syntax for printing. So let me just get rid of that for now. All right. Okay. So about to do this. rm-rf dot. So I'd be like, oh, wait a minute. I didn't mean rf, rm minus rf. I meant ls minus l. So that's how I'm really going to do it. So that's just kind of, I mean, in your next exercise, I'm going to ask you to shell out, and so just for like sanity or whatever. Now this error, I'll try doing it the other way. The print syntax for writing, like normally when we say print, it just goes to standard out. But printing to another file handle, the syntax is sort of terrible. I think I can do dot right there. And then I'll put this together as a plus. I think that's better. So let's see. Now it's doing ls minus l, right? Oh, right. Anyway, so that's the that is the better syntax for that. Alrighty. So let me show you. So those are the two module things I wanted you to work on for this next bit. So let me show you our next exercise. All right. So I'm going to go into day 2 here. And the next one I want to work on is copy special. So as before, there's a printed form of the description of this. So I'm just going to kind of demo through it, but then really you want to look at the printed direction. So it's going to have a part A and a part B. This one's a little smaller, and so I want to spend like a little bit less time on this one. If you don't get to part B, that's OK. Because then the third assignment, the last one, I think is the most interesting, and it's one of the bigger ones. So I want to make sure we save time for that. OK, so here's the idea with this. The idea is that in the file system, there are certain file names which are special. And in particular, I'm going to say that a file name is special if it has the pattern that somewhere in the file name there are 2 underbars and then 1 or more word characters followed by 2 underbars. And then, so for example, in this directory, there are 2 special files. There's the hello and the something. And then the solution directory and copy special, those aren't special. So this is, sort of Google admin kind of thing. You've got all these directories scattered all over the place, and you want to move them around and stuff. So the first thing I'd like to do, let's see. Now, if you run the command with no arguments, it always kind of tells you what the arguments are. So in this case, I can run it just with a directory. So here, I'm going to run it on dot, just the current directory. So if I run it on dot, what I want you to do, so it takes a directory as an argument. What I want you to do is I want you to find all the special files and just list them. And in particular, list them by their absolute paths. The absolute path is something, if you were writing a path to a file or whatever, the absolute path is nice because it's independent of the process that produced it. It doesn't depend on a notion of current directory. It's like, this really is where that file is. So that's the simplest case. Just find them, list them. The next most complicated thing I want you to do is this thing takes a to directory argument. So I'll say /temp / now I'm trying to think of some random word I haven't used. What day is today? Thursday. I'll say Thursday. All right. So in that case, what I want it to do is find all the special files and create that directory if it doesn't exist and copy all the special files to it. So if I now cd to /temp / Thursday and do an ls, oh, hey, check it out. Here they are. All right, I'll go back. That's part B. So then, I'm pretty happy if you get that. But if you just have enough time, then I also want you to have a to-zip, which is very similar to the to directory. But instead, now I want to be able to say blah.zip. And what I want it to do is I want it to find all the special files, invoke the zip utility to zip them all up into the zip file named here. So if I call that, and you can see, actually, my debugging is still in here, right? Command I'm about to do, and then, oops. And then here's the zip command. Zip, incidentally, by the way, I think worst man page ever written. I defy you to find one less useful. It just talks about all the stuff you never want to do, and it never talks about the thing you want to do, my personal experience. So it turns out the command you want is zip-j, and then the name of the zip file, and then you just have all the paths. Now in this case, I used absolute paths. really, the zip is going to have the same current directory as me, so you can do the shorter name, whatever. Depending on your tolerance for that kind of fragility, it's fine. So that'll zip it up. OK, so that's the next exercise. So I'd like you to go ahead and get started on that. And then let's say I'll pull you guys back here a little before 2. And then we'll do the next lecture section. All right, go.